Hello people, this is Self-Tuts and welcome to my brand new series on Kafka for beginners, and in this video we will understand what is Kafka and why Kafka is important these days. So basically you know that the current world is data driven, which means that large amount of data is generated every day and all the software products take decision based on that data. So for an example, a user registration is the main thing for any product. So you need a user so that only after which the product can be used. So once the user is registered, the data for that user is stored in the database, but you need to take a decision that whether that user is registered, so I need to block him. So in that case, the event driven architecture comes into picture, that an event is raised and you take some decision on that event. Kafka plays an important role on all those event-based architectures. So all the bigger companies, let's say Microsoft, Google, Amazon, everyone is using Kafka to make a highly scalable system. And we will understand that how we can make our system scalable through Kafka. So let's see what is Kafka and why it is so much important. So Kafka is just like a messaging system. You can think on a high level or on a macroscopic view that Kafka is a messaging system. So there is a Kafka server, you will get a software, you need to start it and that will generate or start a Kafka server. So this Kafka server will be listening on a particular port or an IP. There are producers which send messages to this Kafka server. As I have said, that it is a messaging system, which means what? Every producer can generate some messages and those messages are published to this Kafka server. There can be multiple producers that can generate messages and publish that to this Kafka server. When the messages reaches this particular Kafka server, then there are consumers which can be one or more than one. So in this case, there are three consumers, C1, C2, C3, and there are two producers, P1 and P2. So all these three consumers can consume the messages from this Kafka. P1, P2 are producer and they send a message, and C1, C2, C3 are the consumer that can consume the messages, and Kafka act as a broker, or it act as a messaging queue, or it act as a system where you can store the messages and then the consumer can read. So Kafka is just like a messaging system on a high level. It is distributed platform or application. So Kafka is often referred to as a distributed application. So you need to understand that why it is called distributed. So in production environment, Kafka is referred as a Kafka cluster. So we'll understand that what is Kafka cluster and why Kafka is referred as a Kafka cluster in production environment. A cluster is made up of more than one Kafka server. So here in the picture you can see there is one Kafka server. So it is not called a cluster because there is only one server. But when you make up a whole environment or a whole setup where more than one Kafka server is there, then that is called as a Kafka cluster. Each Kafka server is referred to as a broker. So when you go into the production environment and you have multiple Kafka server, then each Kafka server is called as a broker. So let's say there is node 1, it is an independent machine where one of the Kafka server is running or Kafka broker is running. There can be another machine. So let's say it is in AWS and other reason, it can be in AWS other reason, and it can be in AWS other reason. Or you can have three independent physical machines on your system, or you can have three different virtual machines where these brokers are running. So on node 1, one broker is running, on node 2, one broker is running, and on node 3, another broker is running. So the combination of all these three brokers is called as Kafka cluster. That's why it is called distributed, because your data is distributed all over the network. It is not present only on a single machine. So as the Kafka cluster says, you can have multiple nodes. So there are three nodes, node 1, node 2 and node 3. So all these three make up the Kafka cluster, and that's why Kafka is called as a distributed platform or distributed application. Since it is distributed, so we'll get to know that what are the benefits of making Kafka a distributed platform or distributed application. So Kafka is a messaging system and Kafka is a distributed platform. Now, Kafka is fault tolerant. So these days, the system needs to be fault tolerant so that it can work efficiently. So what is the meaning of fault tolerant? Ability of a system to continue operating without interruption when one or more of its components fail. So let's say you are having a system which constitutes of more than one component, and even though one of the component is down or it crashed, but your end user should not experience any glitch or any failure. which means that even though one of the component of your whole setup fails, the setup should run as it is expected. So that's why Kafka is called fault tolerant, and we'll see in the later videos that how it is achieved. So in Kafka cluster, messages are replicated in multiple broker. So previously we have seen that Kafka cluster consists of more than one broker, and when you publish a message, then the message is replicated in all the broker based on something which is called as replication factor. So there is a configuration when you create your own Kafka cluster that is called as replication factor, which we'll see in later videos. But as of now, you need to understand that in Kafka cluster, there is a configuration called replication factor, which allows you to replicate your messages in multiple broker. So let's say this is my Kafka cluster and I am having node 1, then node 2 and node 3. So this Kafka cluster constitutes of 3 broker, that is this one, then node 2 broker and node 3 broker. Now when I publish a message, it will be published in node 1 also, node 2 also and node 3 also. When I'm saying that the message is replicated, which means that the message is present on all the 3 brokers. Now let's say the node 1 crashes, or if it is located in a certain place and there the power goes off and everything is shut down. So what happens? This node 1 crashes and all the messages are lost. So what will happen? My message 1 is lost, but since it is replicated in node 2 and node 3, so my message is not lost. So to the end user, if I'm sitting here, I'll see that, okay, I can still access the message 1 either from node 2 or node 3. Let's say the node 2 also crashes. In that case also, what will happen? My message is node 3 is also present, that is M1 is present, and I can say that still I can access M1. But if node 3 also fails, then the message is gone. But in current environment, what happens is that the entire cluster is situated in different geolocations. So it cannot happen that all the nodes are crashed or all the node goes out at a single time. So that's why we keep the nodes in different countries or different geolocation, so that there is a replication and you can access it if one geolocation fails or the other geolocation fails. So Kafka is fault tolerant. Why? Because it is a distributed application and the messages are replicated. So in the later videos, we'll see that how we can replicate this message, on which configuration basis we can replicate the messages. Okay. Now Kafka is a scalable system, which means what? You can scale the Kafka system based on the load requirement. So let's say today you have 1 million users, then your Kafka system is running fine. But let's say the number of users rises to 10 million or 50 million. Then also you can easily scale your system or scale your Kafka cluster. That's why Kafka is called scalable. Now, how you can make this system scalable? You can add new brokers anytime. So you can have new brokers, that is, let's say node 1, node 2, node 3 is there and the load increases. Then you can just add a new node and then your system will become scalable. You can increase the number of consumers also. So suppose you have increased the number of nodes or number of brokers, so you can push more messages by increasing the partitions, which we see later on, but also you can increase the consumption of the messages by increasing the number of consumers. You can make the Kafka system scalable anytime by increasing the number of brokers and by increasing the number of consumers. So this shows that how important is Kafka, that you can scale it easily. You have a fault tolerant system. It is a distributed system. It acts as a messaging queue. You can rely your event-driven architecture on Kafka, and guess what? You can have 1 million requests per second. So you can have 1 million message transfer per second in a Kafka cluster. So this is the throughput, or this is the output of a Kafka cluster. So based on these features, there are so many other features, but I'm not going to discuss everything. I have discussed all the important one, that what is Kafka and why Kafka is needed. Now let's say your system is generating billion messages per second. So in that case, what can happen? You can have multiple Kafka broker and you can publish the messages frequently to that messaging system or Kafka broker. And then you can have large number of consumers which can consume, and those consumers can have the logical code or the business logic code which you can run on those messages, and you can have a desired output. So in today's world, this event-driven architecture is very much important, and most of the systems are designed on this event-driven architecture. And in event-driven architecture, you will need a messaging system. So you can have, means in the market there are multiple messaging system, but Kafka these days is the most important one because of all these features which I have explained. Hello people, this is Self-Tuts and welcome to my series on Kafka for beginners. And in this video we will understand the Kafka architecture. We'll see the different components which makes the whole Kafka ecosystem, but we will not go into the details of each and every component in this video. In the later or in the subsequent videos, we will go into the details of each and every component that makes the whole Kafka ecosystem. Now, let's see what is Kafka architecture. So basically there is a Kafka server. So you have an application or a binary which you spin up and you get a Kafka server. Now this Kafka server have different topics. So you can create multiple topics inside a Kafka server, and those topics have something called as partition. You need to understand that every Kafka server can have multiple topics and every topic can have multiple partitions. So these are the two important things which is present inside the Kafka server. Now in the Kafka ecosystem, there is something called as publisher. So I have denoted it through P1. P stands for publisher or producer. So every Kafka ecosystem can have multiple producer, and these producer can send messages or publish data to the topic. P1, P2, P3 publisher here is not actually publishing to the topic. It is directly connected to the partitions of the topic. So in the later video, we'll see that how messages are published to the partitions and how they are consumed. So in a Kafka ecosystem, we have Kafka server, which constitutes of topic. Every topic has partition, and there is something called as producer. The role of the producer is to publish message and send it to the topic. There is something called as consumer group. So the Kafka ecosystem has consumer group, and there can be multiple consumer group inside the Kafka ecosystem. Each consumer group can have one or more than one consumer instances. So the role of this consumer is what? It is to consume the messages from the topic which was published by the publisher or the producer. Now in here there is a consumer group which has C1 and C2 as the consumer, and there is another consumer group which has C3 and C4 as the consumer. Now these consumers can directly consume from the Kafka topics. So here you can see C1 and C2 is consuming from this topic, and then C3 is consuming from this, and C4 is consuming from this topic. So till now we have seen there can be producer, there can be consumer, and the consumers are associated inside a particular consumer group. A consumer cannot hang independently. It has to be associated through a consumer group. If you want a consumer, then you need to first register to a consumer group, and then that consumer can read from a particular topic. There is another application which is present in the Kafka ecosystem, and it is called as Apache Zookeeper. So Zookeeper is a distributed open source configuration synchronization service. So as the name suggests, or as the wordings here suggest, that it is a configuration management system. Now you can have multiple topics, you can have multiple things, like what are the consumer groups. So where all these data are stored, it is stored inside this Zookeeper. So it is a configuration system, and whenever there is some change in the configuration, then it synchronizes those configuration with the other Kafka things like Kafka server, Kafka producer, Kafka consumer. Configuration or the items on which Apache Zookeeper helps the Kafka cluster or Kafka server is what? Which messages consumer has read. So you need to keep a record, or you need to keep a count of which messages have been read by the consumer. What is the cluster information, that in which location, what is the IP address of the cluster. So as we have seen in previous videos, that in production environment we have multiple Kafka brokers, and those Kafka brokers are called as Kafka cluster. So you have multiple cluster in different regions. So there needs to be some application, or there need to be some system which store all those configuration. What is the IP address? What is the current situation? What is the CPU? What is the RAM usage? How many topics are there? What is the partition? All those data is stored inside this Apache Zookeeper, and also the topic information that I have told previously, that these are the different configuration that can be stored by this Apache Zookeeper. So this act as the data plane and this act as the control plane, which means what, all the configuration are present inside Apache Zookeeper. That's why it is called as configuration system. And it is synchronization because the configuration can change anytime. Let's say this topic is there and it has 3 partitions, but later on if we see that okay, load is increasing and we want to increase the number of partitions, so what will happen, we'll increase the partition here and that information will be sent to the Zookeeper and then Zookeeper will send it to the consumer. Or if some changes are done inside the consumer, then those information will be sent to the Zookeeper. So this whole ecosystem is present, which is the Kafka architecture. So again I'll repeat, there is producer which publishes message to the topic, there is consumer which consumes messages from the topic, and there is Apache Zookeeper which keeps the synchronizations between all these systems and it keeps the configuration for all those systems. So this is the whole Kafka architecture which is present. This is a high level view. We'll go into the detail of every component, that is producer, topic, partition, consumer, everything in our subsequent videos. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we will install Kafka and Zookeeper. So in the previous video we have seen the Kafka architecture, and two of the most important component of the Kafka ecosystem were the Kafka server and the Zookeeper. So we need to have the Kafka server and Zookeeper up and running, then only we can do some coding, we can publish message, we can consume message. So it is very important to install these things on your machine. So I'm doing it for Linux environment because I'm using Ubuntu, but it will be quite same for all the Linux environment. You need to see about the Mac, and I think for Mac also it will be same, and you need to search for Windows that how you can install it. This is not a mandatory one. If you have a Kafka server up and running, then it is very good, you can use that one. But in this video we'll learn how to install it. So basically we need to download the software. So when you download the software, you will find both Zookeeper and Kafka server in the same downloaded file. So I'll go to my Chrome browser and here I can say Kafka download. So you need to just search it because you need to always install the latest one which is present there. So this is Kafka downloads and there is something called as this thing. Okay, so you have 2.5 and release node. So there is binary downloads also based on Scala and other thing. What I'm gonna do here is there is something called as quick start, and in the quick start you will see the download steps. So you can follow this one also to download, or you can continue this video. So if I click on this download button here or the link, you see that I am going to this apache.org. Here you can find the different link which you can use to download. So I'll just clone it and then I'll use it. So I'll use this copy link address and then I'll go to my Linux box. So for my Linux box, I'm using Ubuntu 18.04. You can use any Linux box, and moreover for everyone, the installation step will be same. So I'm opening my tmux so that I can open multiple terminal, and then I'll go to OPT. So OPT is the place where I install all my software in my Linux environment. So I'll do a wget to download it, and I have already copied the link so that I can get the data that is present here. So it is saying that issued certificate has expired. So I think this link is not correct. Let me copy this one. So I'll copy this one and I'll do wget, and again I'll paste it. So this time I think it will be able to fetch the, yeah. So you see that you can easily download this one, and I'm having a nice speed, let's say 5 Mbps, and it is saying that 4 seconds is left, 3 seconds, 2 seconds, 1 second. Okay, so now the tar file has been downloaded and you can see it is listed here. I'll do what? I'll unzip this tar file. So that is tar -xvzf and then Kafka, the tar file name. So this will do what? This will untar or basically unzip. So you can see we got a new folder here, that is Kafka. Now going on to the slides, you can see that for the Kafka server we have a config file called as server.properties, and for the Zookeeper you have a config file as zookeeper.properties. In the Kafka architecture we have seen that both these systems are important for the Kafka ecosystem. So you need to start both of this, then only you can do something like publish message and consume. So both the things are important, and for Kafka the configuration file is server.properties, and for Zookeeper it is zookeeper.properties. Now the most important configuration that you need to change in Kafka is what? Advertise listener. So it will be something like this, and you need to put your IP address here so that the other people can consume it, or from other machines you can access this Kafka server. After that, you need to set a setting here, that is Zookeeper connect, because this Kafka server should know that which Zookeeper I need to connect to. So for that, you need to provide the IP address and the port. So generally the port is 2181 for Zookeeper, and for Kafka server it is 9092. So these are the default port. If you want to change, you can change them. After that, you can start the Kafka server using this particular command. So there's something called as JMX port equal to 8004. This is needed because we want to expose the JMX service on our Kafka server, because later on in the subsequent video we will be installing the Kafka manager which needs this port. After that, we will see the Zookeeper, and the Zookeeper is having the properties file as zookeeper.properties. And once you install everything, then you can start the Zookeeper using bin zookeeper server start.sh and the config zookeeper.properties. So you'll see that all these sh files are already present in the thing that we have downloaded. So this is the particular folder where all my components or all the things related to Kafka is present. So I'll go inside the cd Kafka, and if I go inside bin, then you can see that there are different sh files which are present, and one of the sh file is what? Kafka server start, which will help us to start our Kafka server. So you can see here Kafka server start.sh. After that, you can also see the Zookeeper server start.sh. So if you find something as Zookeeper server start.sh, so this will also help you to start the Zookeeper. So these are the two sh files which will help you to start your Zookeeper. So now the sh files are there. We'll go inside this config folder which is present here. As you can see, I have gone inside this config folder, and here you can find there's something called as server.properties. So this server.properties is the properties file for our Kafka server, and there's something called as zookeeper.properties, which is the properties file for our Zookeeper. We need to make these changes in the server.properties file. So I'll just open it, and then you can see there are different properties. You can go through them, you can read them on some documentation online, you can understand everything. But what we are interested in is what? Advertise.listeners. So we can see here that there is something called as advertise.listener, which is already commented. So I'll just comment it out, and then what we can do, we need to put our IP address. So the server Linux machine which I'm using is having an IP address of 192.168.0.10. If you're using everything on a localhost environment, then you can just put here localhost and it will run fine. Either ways, you have to find the IP address of your machine and you need to put it here. Now this configuration has been done. After that, you need to write the zookeeper.connect. So I will search here zookeeper.connect, and if I go down, so there will be something called as zookeeper.connect. Now zookeeper.connect is present here. As I'll be installing Zookeeper on the local environment only, so I can just provide here localhost 2181, or also I can provide the IP address. So I'll just use the IP address. So I'll give 192.168.0.10. So this is my IP address. I'll save this file. Once this configuration is done, I don't need to change any configuration related to Zookeeper for this series. So basically both the configurations are perfect. Now I'll go one directory up so that I'm present here and I can see the bin folder is present here. Now first what we need to do, we need to start the Zookeeper, because once the Zookeeper is started, then only the Kafka can connect to it. So the command is what? Sbin, and then you can see, I'll give it in the description of this video that what is the command, or you can see from here bin zookeeper server.start.sh, and after that you need to provide the config file. So it is inside config folder and then zookeeper.properties. I'll hit enter and you can see the Zookeeper server has started, and config info binding on port this one. So it has started on 2181. Once the Zookeeper server has started, we need to start the Kafka server. So for that we need to use this command. So I'll just use jmx port, jmx_port is equal to 8004, and after that we need to use bin. And okay, it is not present here. I'm inside this self-test master. So first I need to go to the opt folder, and here I need to go to the Kafka folder. After that I need to type the command jmx and underscore port, okay, equal to 8004. So once this port has been exported for JMX service, then we need to use bin, and then we need to use the Kafka server start.sh, and we need to provide the config file. So the config file is what? Config and server.properties. Now one thing you will see that as soon as this server is started, you can see on the left hand side there will be some log write that the successful connection has been made, so there will be a log write. So I'll come to the right hand side again and I'll hit enter. So as soon as the server starts, so waiting until Zookeeper connected. Okay, so Zookeeper connection is, it is saying that Zookeeper is not connected. Okay, now you can see creating a new log file, and Kafka server started and the Zookeeper connected successfully. That's why we were getting a previous message or waiting for Zookeeper. But once the connection has been done, then you can see that there's a log write also, and this server has also started. So this server started at port 9092, which you need to remember because that is the default port. And for this one, Zookeeper, this is 2181. So Zookeeper starts as 2181 and the broker, that is Kafka server, starts at 9092. So in this way, what we have done, we have installed both Kafka server and Zookeeper. So both are up and running. So this was all about this video, that how to install Kafka and Zookeeper in your system. So I have done it for Ubuntu 18.04, but more or less it will be same for every Linux environment and also for the Mac environment. So for Windows, you need to search somewhere on the internet that how to install Kafka and Zookeeper. It is very simple. And then later on we can write some code through which we'll see that how we can produce the messages, how we can consume the messages. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we will install Kafka Manager. So Kafka Manager is a graphical user interface to view your Kafka cluster. So when we have installed Kafka server and Zookeeper in our last video, so we have seen that we downloaded the files inside OPT and then Kafka. So this is the folder where we unzip or untar this particular tar file, and we got all these particular folders and file here. So one important folder is cd bin. If I go inside it, then you can see here there are so many sh file or script files through which you can perform so many actions on the Kafka server. Like if you want to get the list of all the topics, all the partitions and other thing, then you can use this Kafka topics.sh. If you want to start a Kafka console consumer, then you can use this Kafka console consumer.sh. So if you want to delete records, if you want to then mirror the Kafka, then all these things can be done through these sh files. But in the world of Kafka, I'm not so much fan of this sh file because you have to understand so many options, then you have to remember it, and then only you can perform a particular action. For this, basically I use a graphical user interface that is called as Kafka Manager. So we'll be installing it. So it is a graphical user interface to view the Kafka cluster. So basically you can view all the topics, view all the partitions, the number of offset, which are the consumers which are assigned to a particular topic or to which partition. Up to this much you can view here. So we'll see the graphical user interface of that after installing it, and you will see that how awesome that particular Kafka cluster is. So basically the prerequisite is what you need to have Java 11 installed on your machine, and then only you can do this, or you can compile the Kafka Manager and then you can start the Kafka Manager. So what we are going to do, we are going to this repository that is Yahoo CMake in GitHub, and there you can clone it and then you can perform the action. I'll go to the Chrome browser and here I'll say CMake. You can also search for that CMake GitHub. So this will take you to this Yahoo CMake, and this is the Kafka Manager. So it is called as what? It is called as Cluster Manager for Apache Kafka. Previously it was known as Kafka Manager, but now we have got a new name, that is Kafka Manager for Apache Kafka. So if you see here, then you can define the clusters in this, that is what are the different clusters on which you want to work. So you can have one or more cluster defined here, and then you can see all the clusters. So what are the brokers present, what are the topics present, what are the consumer present, what is the preferred replica action, so how the topic contains which partition, and everything can be seen here, like what is the consumer that is present. So we'll install it, then we'll see that how easy it is to install, and then how useful it can be when you are viewing your own Kafka cluster. So what I'm going to do here is I'm going to go to my slide, and then after cloning this particular repository, we need to run this command, that is spt clean and dist. So this is a command, you don't need to bother about it, you just need to clone this folder. So I'll just do what, I'll come here in the top, and here you can see there is a clone drop down here. So I'll just copy this and I'll go to my Linux box. Here I'll come to OPT because I install all my software here, and then I'll do a git clone of this particular repo that I have just copied. So I'm cloning it, and what it will do, it will try to download all the files from GitHub repository. So once this has been downloaded, then what we need to do, we need to run this command /sbt clean test. So it has been cloned, and after that I'll go inside CMac folder which was cloned, and then you can see there is a sbt thing present here. So the prerequisite is what, you need to have Java 11 installed. So I'll check my Java version, and you can see that the Java version that I'm using is 11.0.7. So you need to have this, you can download it from anywhere, and then you can install your Java 11. Once that is done, so I'll say sbt clean and then dist. So I'll just run this command, and this can take some time. The Kafka manager has successfully compiled, and if I do a listing, then you can see here that a target folder is created. So inside the target folder, if I go, then there's a universal folder. So I need to go inside this universal folder, and if I do a ls, so there is a cmac 3.0.5.zip. So what I need to do, I need to unzip it. So I'll unzip cmac, and this will unzip all the files, and it will give me a new cmac folder, and I'll go inside it. And after that, there is something called as bin. So I'll again go to my slide and see how we can start it. Once the compilation process is successful, then you need to change this CMac ZK host with your Zookeeper host ID and the port number. And this is present where? It is present inside this application.conf. So this application.conf is present inside the folder that we have come, that is CMac 3.0.5. So we first entered inside the target, and then we again got this zip file, we unzipped it, and then we'll go inside this conf, and here you can find the application.conf. So I'll just open this file, and here you will see cmac.zk host. So cmac.zk host is there. Here you need to provide the IP address of your Zookeeper. So the Zookeeper I am running is on my local machine, and it is having an IP address of 192.168.0.10. So this may differ in your case, and you have to provide the IP address of your system where Kafka server is running or the Zookeeper is running. So it is basically Zookeeper IP address, and since the port is 2181, which is the default port for Zookeeper, so I'll just save it. And after saving, what we need to do, we will go to the slide and see that how we can start our Kafka manager. So it is bin/cmac and then d config file, the path of the config file, and the port where you want to start. So I'll just come one folder up, and here I'll say bin cmac, and after that -d config. So this is the -d config dot file will be equal to conf/application.conf. So this is the application file which we have already seen, application.conf. So it is -d config.file, -d config.file equal to this, and then the port where you want to start. So it will be -d http.port. And the port number what I'm giving here is 8080. So you can give any port whatever you want, it's up to you. So I'll start it, and then it will take some time to start the Kafka manager server. So I have already started my this Kafka server and Zookeeper in the previous video here. So these are the two running one which I have shown in the previous video. I'll do again what, I'll just close this running here in this particular tab, and I'll just close it. So it has started, but I'm closing it off now so that I can start all those inside a single terminal. So I'm doing a Control-C here, so the existing server will close, and I'm also doing a Control-C on my left hand side. So now you can see I'll clear the screen everywhere. So this is also cleared, and this is also clear. Okay, so now I am present where? Inside my Kafka folder. So first what I'm going to do is I'm going to start my Zookeeper. So basically I'll start this Zookeeper. So here you can see bin Zookeeper server start.sh and then config zookeeper.property. So I'll start it. So it will start my Zookeeper. Then on the right hand side, if I come, I'm starting the Kafka server and I have provided this JM export. So in the previous video, I have explained that we'll need a JM export, and this JM export is needed by the Kafka manager. So I'll hit enter and this will start my Kafka server. So once this Kafka server started, you can see there's a log, right, creating file, new log file, which means the connection was successful. Now I'll split this right hand side into two pane, and again I'll start my Kafka manager. So I'll go to OPT and there I'll go inside CMake and then again inside target and then universal and then CMake folder. Here what I'm having all the files, that is bin and other thing. So I'll just go here bin slash and then I need to see the command CMake -d and then config.file is equal to what? It is equal to conf slash application.conf and then -d and then -d is what? http.port. So this will be equal to what? 8080. So this is the command bin CMake -d config file conf and this. So I'll start this Kafka manager. It will take some time to start. So it has already started on this port 8080. Now let me allow to go to the browser, and here what I'm going to do, I'm going to type the IP address of my local machine where I'm installing all these things and I'll hit enter. Kafka manager is up and running. Here you can find the cluster and then you can either list or add a cluster. Since we are interested in adding our cluster, so I'll add this. So I'll keep the cluster name as self-turts, and after that you need to provide the cluster Zookeeper host. So if you are having more than one Zookeeper, you can provide a comma separated address, but I'm having only one Zookeeper which is present at 192.168.0.10.2181. So it is here. Then I'm using the Kafka 2 for 2.4.0 above version. So that is that I'm allowing this JMX polling because it will help me to poll the consumer and give some messages. So it is not important to understand, but just take this one, enable JMX polling. After that you need to poll the consumer so that you can get the information frequently, that what is the current offset and other thing and how the consumer is performing. So after doing this check, I'm keeping all the thing as default. So now we have added the cluster and I can go to the cluster view. So here you can see this is my cluster information, that I'm having broker as one, which we have already seen that in Kafka, every Kafka server is called as a broker. So we have one broker in this Kafka cluster and this has 192.168.0.10 as the IP address. Again, you can see there's only one topic. So by default, Kafka generates a topic that is called consumer offsets, which records the offset of all the consumer which has connected to this particular Kafka cluster. So this topic is automatically created and it is created by Kafka. So you don't need to take care of that. Now what happens if you want to create a new topic? So let's say I want to create a new topic. So I can create a topic, give the topic name, what is the partition, what is the replication factor. This we'll learn in subsequent videos, what is the importance of this partition and replication factor. So you can create a topic from here. So once the topic is created, you can see the details about that topic, which we will see in the later videos. Then the broker information, what are the messages per second, bytes per second, all this information can be achieved here. Also, you can add more than one cluster. So either you can modify it or you can disable it. This is the way how you get a Kafka manager or the graphical user interface for your Kafka cluster. So you can see how easy it is to use. You will see the importance of this Kafka manager in the later videos when we write the actual producer, when we send actual messages and the consumer is consuming the actual messages. You can see all those listing there. If we would not have been using this, then what we would have to do, we would have to go to this /opt, then inside this Kafka folder, then inside this bin folder, and then you can use this Kafka topics.sh to list all the topics, to create a new topic, another thing. So it is quite tedious. It is beneficial if you learn these sh file, that is script file, what are the different options and parameter, but I'm not a good fan of it because I use this Kafka manager, which comes very handy and it is very easy to visualize your Kafka cluster. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we'll understand one of the most important component of Kafka ecosystem, that is called as topic. So we'll be reading about what is Kafka topic. So topic is the Kafka component where producers are connected. So if there is a Kafka ecosystem, then your producers will be connected to the Kafka topic. and the producer publish messages in this Kafka topic. So the role of a producer or publisher is to publish a message, and those messages will be published to the Kafka topic. So suppose this is a Kafka server. So this black region defines the Kafka server, and there is a topic inside it. The name of the topic is topic 1. So there is a producer that is called P1, and it is connected to this topic 1. So producers are connected to topic. And the topics in Kafka is multi-subscriber. So if you see this topic, there is one producer. There can be more than one producer to it also, but more or less Kafka topic is multi-subscriber. So you can have C1, C2, C3 as the consumers which are subscribing from this particular topic, that is topic 1. In the Kafka ecosystem, topic plays an important role where the messages are sent and then the consumer consume it. So the producer or the publisher are the entities or the component of Kafka ecosystem which publish message to topic, and then the consumer consume those messages. Topic can be considered as the logical entity. In real sense, when a producer sends a message to the topic, then it is not stored inside the topic. If you go deep inside the topic, there is something called as partitions. So the messages which are published by this Kafka producer is stored inside the Kafka topic partitions. In Kafka cluster, each topic is present in every cluster node. So as we have learned earlier that a Kafka cluster consists of more than one nodes or more than one broker. So as the topic is a logical entity, so in a Kafka cluster, it is present inside every cluster node. So let's say this is a Kafka cluster and you have node 1 and there is a Kafka broker. There is node 2 and there is another Kafka broker, and there is node 3 and it is also having a Kafka broker. So this Kafka cluster is made up of 3 machines or 3 nodes. Now the topic will be present here also, and here also. So this is a logical definition that if you are creating a topic inside a Kafka cluster, then it will be present inside every node or every machine of that cluster. So topic is the main entry point where publisher publishes the message and consumer consume from it. So this is a high level idea of what topic is. We'll go into the deep of the topic, that what is partitions, how consumers are connected to the partitions and everything in our subsequent videos. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we will learn about Kafka topic partition. So Kafka topic partition is the most important concept that you need to understand if you want to design a highly scalable Kafka architecture, or if you have a product where the Kafka is needed and you need to design a scalable system. So topic partitioning concept is the most fundamental and the most important, which will lay the groundwork, and then you can design any architecture whatever you want. So let's go into the details of Kafka topic partition. A Kafka topic is divided into multiple parts, and that is called partition. So in the previous video we have seen what is a topic inside Kafka ecosystem. So if you go inside the topic, then that topic is divided into multiple parts, and those parts are called individual partitions. Partitions can be considered as a linear data structure, just like array. These are also called as commit log. So let's say this is a topic. So this is a topic. I'm representing it with this structure, that is this symbol. So this is a topic and this is the partition. So inside a topic, you have an array-like data structure, and this array-like data structure is called the topic partition. Messages are actually published to a topic partition. So basically we have learned in previous videos that a publisher sends the message to a topic and the topic stores it. But in real sense, the messages are actually stored inside this topic partition. So this topic is a logical entity, but the real entity is what? It is topic partition. Now, every partition has a partition number. So if you create a partition inside the topic of Kafka, then they will have a topic partition number, and this designates the topic partition number. So you can say that 0 is the partition number for this particular partition. Each partition has an increasing index called offset. So if you see here, then if this is an array, then what will happen? It will have its own index, that is 0, 1, 2, 3, 4, and it will go up to long means it's up to the requirement that how many data is stored, what is the size of the data and other thing. So this index is called as partition offset. So you need to understand this terminology regarding the Kafka topic and Kafka partition, which will help you later on. So every partition has a partition number, and every partition has an increasing sequence of index that is called as partition offset. Now, new messages are always pushed at the rear end. So if you want to publish a new message, then you will always write at the end. So suppose you have published the message at this index 1, then you can't mutate it. That is why data is immutable after publish. So once you have published the message inside the Kafka partition, then what will happen? It is immutable. You can't replace it or you can't modify it. If you want to publish a new message, it will always get appended at the end or at the rear end. So this is the data structure which forms the base or the core of your Kafka ecosystem. So inside the topic is divided into multiple parts, and these parts are called partition. Every partition has a partition number and increasing sequence of index that is called as partition offset. Now let's see this example in which there is a broker and there is a topic with one partition and single broker. So this is let's say this is a machine where only one broker is present, and we are creating a single topic and the number of partition is only 1. So we have shown here that the number of partition is 1. In that case, you will get this array like data structure where you will have only one partition and the partition number is 0, and the offset starts from 0, 1, 2, 3, and it is ever increasing. Now let's take the second case where we have a topic with 3 partition and the single broker. So let's say we have divided our partition topic into 3 partition inside a single broker. So the Kafka server that we are running is only one, and there is a topic. Let's say the name of the topic is topic 1, and we have divided that topic into 3 partition. In that case, all the partition will be present inside that particular Kafka server or Kafka broker. So the partition number will be what? It will be 0, 1, 2. So there are 3. So it starts from 0 and then 1, then 2. So these are 3 different partitions, and these are 3 different commit logs, you can say. And every partition has an increasing index that is called partition offset, and it starts from 0, 1, 2, 3, and it is ever increasing. All the partitions are immutable, which means what? You cannot delete or modify the messages which are present at a particular offset. You can only append new messages at the last. So this was the example with a broker having only one partition inside a topic. So you have to understand it that this is topic, the blue color is saying as topic, and there's one topic, single topic. It is present on a single broker, that is only one Kafka server, and the number of partition is 1. So we got only one array like structure. Here what we have, the broker is only 1, which means only one Kafka server is running, but we have 3 partitions inside a single topic. So we got 3 array like structure. So this is inside a single broker. Now in case of multi-broker Kafka cluster, partitions for a topic are distributed across the whole cluster. So in our production environment, we always use a Kafka cluster where there is more than one broker. So in that case, the partitions will be distributed across the whole ecosystem, that it can be present in different nodes. So let's take an example here. So let's say this is a Kafka cluster with a topic. So there is a single topic, for example, we are taking with 4 partition and 3 broker. So you need to understand there are 4 partitions for the topic and the number of brokers are 3. So as soon as we see that there are 3 brokers, which means that 3 machines are there and 3 different Kafka servers are running. So there is broker 1, there is broker 2 and broker 3. So these are the 3 machines where the Kafka server is running, and we have created a topic. Let's say it is topic 1. So all the topics are present here. So as I have said previously also, the topic is just a logical entity. So we can say the topic is present on all the 3 servers, that is broker 1, broker 2 and broker 3. Now there are 4 partitions, and this 4 partition will be what? It will be distributed across the whole cluster. So if we take the example, then the partition 0 will be present in the broker 1. So let's say when the Zookeeper was assigning the partition 0 was assigned to broker 1. The partition 1 was assigned to broker 2. The partition 2 got assigned to broker 3. So it is not sequential that it will be in sequential number. So we can get the partition 2 in broker 3, and then again the partition 3 can be present inside this particular broker 2. So this can be anything, it can be random. All the 3 can be present here only, or 1 is present here only. All the 2 can be present here, 1 can be present here. So the 2 partition can be present here, like let's say 1 and 2 are present here, 0 will be present here, and 3 will be present here. So this is random, but the important concept that you need to understand is what? In Kafka cluster, the topic partitions are distributed. It is not in a single broker. It can be anywhere inside any broker. So 0 is here, 1 is here, 2 is here, and 3 is here. So that if you are having 4 partitions, so all the 4 partitions will be distributed. So let's say you are publishing a message. So the first message can go to this one, that is broker 1. The second message can come here, and the third message can go here, and the fourth message can again go here, or the fifth message can again go here, because the partitions are distributed across the whole cluster. So this is the scenario where you have a Kafka cluster and you have 4 partitions inside a single topic. So we are partitioning a single topic into 4 partitions. So the partitions are distributed across the cluster. So hope you understand this concept, because this is the important thing from where you will understand how the consumers are consuming from the topic, how we can increase the efficiency of the whole Kafka ecosystem that we have developed, then how we can set the replication factor and other thing. So this particular thing needs to be understood clearly, then only we can move ahead. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we will learn about writing a Kafka producer in Python. So we'll be using Python as our programming language for understanding this whole Kafka for beginners series. So Kafka producer plays an important role in the Kafka ecosystem, and we'll understand that. Producers publish message to the topics of their own choice. So as we know that producer publish messages to the topic, so they can choose the topic of their choice, which means they can get connected to a particular topic and then they can send the message there. In reality, messages are published to topic partition. So if you see that under the hood what is happening, producer or the publisher will send the message to a topic partition. So let's say this is a topic and it contains 3 partitions, P0, P1 and P2. So with this blue box, I have designated a topic, and this topic contains 3 partitions, P0, P1 and P2. And there is a publisher. So what this publisher will do, it can send the messages to all the partitions. So basically what will happen, first time it will send to P0, and then it can send to P1 and then P2, and then to, in a random fashion, it can send it to any partition whichever it wants. When you see this structure, you can see that there is a publisher and there is a Kafka server where this topic is present. Configuration is needed for the Kafka producer so that it can send the message. So what are those configuration? First thing is the bootstrap server. So let's say you are writing a publisher or a producer, then you need to know about the Kafka server address. So that is called as bootstrap server. So basically you give a bootstrap server address, that is basically a IP address and a port, and the default port for the bootstrap server is 9092. So the publisher can connect to this topic only when it knows the bootstrap server address. After that, what will happen? It needs to connect to a particular topic, which we have seen here, that producer publish message to the topic of their choice. So the configuration that is needed by this publisher is what? It needs the topic name where it want to publish the message. After that, it needs something that is called as value serializer. So whenever you are sending data over the wire, then it should be serialized, which means that it should be ASCII converted or it should be a simple string so that it can be sent over the wire. It should not be a object. When you are sending a message to this particular topic, then those values should be serialized, and that's why you need to define a value serializer. That is basically a method which returns the serialized value. So we'll see all these things when we write our own producer. So in this video, we'll be using this library Kafka Python to create a producer or a publisher that can connect to the Kafka topic. Then we'll be using the send method on that producer to publish the data. So once we have created a Kafka producer, then we'll call the send method over it. We'll also use another module that is called as faker, which means what you can fake the data. You can create randomly faking data, which will be useful when you are publishing the message, so that you can identify that there are different messages which are being published. So what we will be doing, we will be trying to create a scenario where users are getting registered and the registration data is present, like name, age, and something address. These things can be present there. Now, the first case is what we will be taking an example of single broker and one partition. So we will be taking a Kafka cluster where only one broker is present, and inside the topic there is only one partition. So in this scenario, what will happen? All the messages will be published to a single partition. Let's say this is the topic and it contains only one partition. In that case, the publisher will do what? Let's say the publisher are publishing 100 messages. So all the 100 message will go to this partition because there is only one partition. Taking on to this case, that is, there is a single broker and there is one partition. In that case, all the messages will be published to the single partition. Let's create our first Kafka app. So I'll open my terminal here and I'm going to create a folder for my project. So inside D directory, there's a workspace folder and here there's a Python folder. So generally I create all my projects here. So if I do a ls, so there is already these folder. I'll just try to delete this Kafka app folder. So let's say now there's no Kafka app related folder. So I'm going to create a new folder that is called Kafka app demo or Kafka app demo. So this is fine. So now I'll go inside this Kafka app demo and you can see it is empty. I'll be using IntelliJ IDEA to do my coding. You can use any IDE of your own choice. The initial setup will be different, but after that everything will be common. That is the coding stuff. So I'll go inside this D drive and there is workspace and there is this Kafka app demo. So I'll select it and I'll open it. Once you open a Python related project inside IntelliJ IDEA, then what you need to do, you need to define the SDK. So I'll go inside file and then this project structure and then this SDK. So here what I'll do, I'll define a new SDK and I'll go to this add Python SDK. So I'll be using virtual environment to create my project. So this virtual environment creation can differ based on your IDE, based on your thing that you're using. So you can skip this part if you're not using IntelliJ IDEA. So you need to create a virtual environment in your Kafka app demo folder and then you need to do OK. So once this virtual environment is created, then you need to select this virtual environment inside your project. The virtual environment SDK, as you can see here, Kafka app demo is successfully created. Then I'll go to project and I'll select that SDK here. So that is Kafka app demo. I'll hit apply and then OK. So this SDK is already created here, and if you see now, the virtual environment folder is created. Initial setup for our Python development is already done. So I'll not be creating this setup again and again in subsequent videos. So this is the one-time setup in this particular video. In the later videos, this will be common. That is, the virtual environment will be present there, and then you need to install the libraries and other thing. So once this is done, as we have told in our previous slides, that we will be using what? We will be using Kafka Python and the faker libraries of Python to create our project. Now, what I'm gonna do here is I will be creating a, I'll be installing those libraries. So I'll open my terminal and I'll say pip install Kafka Python. So I'll be installing it. So I'll say pip install Kafka Python, and what this will do, this will try to fetch the Kafka Python from pip repository and it will install that inside this virtual environment folder. So as you can see, it has been successfully installed. Now once this is installed, I will again try to install what? The faker library. So I'll say pip install faker. So this will install the faker library in my virtual environment folder so that I can just activate this environment and then I can use it. So you can see here that this is already activated. In my previous video, we have already installed Kafka server, Zookeeper and the Kafka manager, which are already running. So I'll go to my Linux box here and you can see this is the Zookeeper, this is Kafka server and this is Kafka manager. So all these three are running. You can have your own setup if you want, or if you're following this particular video series, then this is the way that we install. So I will open my Kafka manager and this is the Kafka manager. So self-tuts and this. At present here only one topic is present. So I will try to create a new topic inside my self-tests cluster so that I can push my data here. So I'll just say create and then the name of the topic. So the name of the topic will be registered user. And in this example, what we are going to do is we are going to explain a scenario where we will have a single broker with one partition. So there is only one partition present. When I'm creating the topic, I will give the number of partition as 1. So I'll hit create and this will do what? This will create my topic. So you can see that how easy it is to look the topic. So inside my self-tests cluster, now there are two topics. One is the consumer offset. That is the predefined topic which Kafka already creates, and I have created this new topic. So if I click to registered user, then you can see the different data related to this particular registered user. You can also see here the number of partition is only 1, so it is only 0, and now there is no consumer attached to it, so there is 0 here. So there is no listing here. So basically this is the place where you can see all the messages that are flowing, what is the current sum of the offsets and other thing. So we will go into the deep of these things when we start publishing the message. Now the topic has been created, and then what we're gonna do is we're gonna write our first producer. So I'll create a file here that will be called as new and then Python file, and it will be called as producer.py. Now I'll be coding here on my producer.py, and the first thing that I need to import is what? From Kafka. So as we have installed Kafka Python, so this gives us from Kafka import and then what? Kafka producer. Let's define the Kafka producer, and we know that for defining a Kafka producer, we need to know some config values, which are basically the bootstrap server and the value serializer, because we always want to send the data in the serialized format. So I'll be creating an instance of this producer, and that will be equal to what? Kafka producer. Now this Kafka producer needs to connect to a Kafka server or the broker. So we need to provide that address inside a configuration. So that will be bootstrap underscore servers, and that will be equal to what? We will give it as an array, and I know that my server is running at which port? 192.168.0.10, and the IP address is what? It is equal to 9092. Fine, I'll just make this smaller. Okay, so this is the first parameter that we are providing. This is the instance that we have created, and now we want to send some data. So for sending the data, we need to get the data. So I'll be creating a new file here inside my Kafka demo, and that will be equal to new Python file, and this Python file I can say as what? Data.py. So here there is this will be the file where all my data generation will be done. So inside here, what I can say is basically I'm importing the faker module. So I'll say from faker import faker, because we are using this faker module. If you want to learn about the details of this, then you can just visit the GitHub page for that. So I've created this, I've imported this, and then I will take an instance of this faker. So I'll say fake is equal to faker. So I'm creating an instance, and then I'm doing what? I'm defining a method. So I'll say get registered user, and this registered user will be equal to what? It will return me something. So that data will be equal to return, and inside here the first thing will be what? It will be the name of the user. So what this faker library does, it returns you a random string every time. So I'll say fake.name, so it will return me a random name. Then I can say address, and that will return me a fake address. So I can just say fake.address, that is a method there, or a provider which you can use. Then I can say the created at field. So I'll say created at, and that will be equal to fake.year. So these are the three things that we are currently taking, that is name, address, and created at. If you want to test this file, then we can just do it here, and I will say what if underscore name equal to underscore main. So this will run whenever you run the file using python app.py. So I'll just say print and then get registered user. So I will come here and then I'll just run it. So here you can see I got a random name. So you can see the name is Amy Hughes TVM, address is this, and created this. If I again run it, I'll get a random name and random address. So this is the importance of the faker module that we are using. My first method is done. So I think the spelling was wrong. So I'm gonna just correct it. So I'll say get registered user. So this will give me a fake data. Now, since I'm creating a producer, so I need to send the registered user. So we are mimicking what the user registration is taking place and we are sending the data. So I'll come here and then I'll say the value serializer. So the value serializer will always be a method. So I'll say value serializer, and that will be equal to what? It will be equal to method. So I am returning a JSON registered user and I'll be sending that same registered user. So I'll say JSON serializer. This is a method that I need to define. So I need to create this method. So again, after here, there is no method defined. So it is in red. So I'll say def and then JSON serializer. So this JSON serializer will do what? It will accept the data. So when this producer is gonna run, so every time what will happen when you will be sending a data, it will call this JSON serializer method over that data, and then you need to return something. So in the return, I will just serialize it. So serialization of JSON is very simple. So you need to just import JSON, and after that what you need to do, you need to return JSON dot dumps and then the data, the JSON data, and then you also want to encode it so that when you are deserializing it, then all the text are based on UTF-8 encoding. So this is encode and then that will be equal to UTF-8. So this is the value serializer that we have written. So the Kafka producer is getting connected to this Bootstrap server or the broker, and the value serializer is this. So up to here, everything is fine. Now what I'm gonna do is I am going to write this method. So if underscore underscore name equal to underscore underscore main. So I'll be running it using python app.py, and because of that I need to write that. So if underscore underscore name is equal to underscore main, so I'll create a infinite loop, and that will be created using while 1 is equal to 1. What I'm going to do, I'm going to create a registered user, and that registered user will be from where? It will be from the data file that we have created. So inside the data file we are having this get registered user. So from data import get registered user, and that get registered user will be called here. So every time when this loop is running, I'll be getting a registered user data. So once this registered user data is present, then what I'm gonna do is I'm going to send it to the Kafka server. So in the slides we have seen that if you want to send the data, you need to call the send method over the producer instance. So we have already given this Bootstrap server, and we also need to provide this topic name and value serializer. So while sending the data, we'll provide the topic name. So we'll say producer dot send, and then this send will be called inside the topic name. So that will be equal to registered user. So this should match the name that is present here. So I'll just copy it from here. So I'll say copy, and then what I'm gonna do is I'm gonna paste it here. Fine. So this is producer.send. So the first argument is what? It is equal to the topic name. After that, we need to provide the data that we need to send. So as we are going to send this registered user, so I'm giving this registered user, and we have already given this value serializer. So what it will do, it will take this data and then it will run this particular method over it, that is JSON dump. So it will automatically serialize. Now let's say it is while loop, and after this I'm going to give a slip so that it is not very frequent. After some time period, it is publishing the record, let's say 3 seconds or 5 seconds. So what I'm gonna do is I'm going to import a new module here, that is import time, and from the time I'm going to call the sleep method. So the sleep method accepts a parameter which is in seconds. So let's say I'm giving a value of 4. So what this will do, that every after 4 seconds it will publish a record. Fine. Now I'll be going to this Kafka manager, and you can see here that in the current partition the latest offset is 0, so there is no message present here, or in the sum of partition offset also there is 0. So if I reload it, you can see this is 0 and this is the partition number. So I am writing a producer, and that producer will be sending the data to this topic registered user which is having a single partition. So what will happen, all the data will be sent to that particular partition only. I am also going to print the data. So I'll say print and then registered user. So every time when we are sending the data will be printed. Now let's run this producer and see what is happening, that it is able to send the message to the Kafka broker or not. So let's run this, and you can see here that we got first message, that is name equal to this, and after every 4 seconds we are publishing the message. So still we are not consuming it, we are only publishing it. So what we are doing, we are publishing it the topic registered user. Now let's go to our Kafka manager here and just reload it, and you can see that the latest offset is 5. So you can see that we have created only one partition. So if you see the current registered user, so there is only one partition. That's why all the messages are going to this partition only. So if I reload it, so you are seeing that latest offset is 9, and here the sum of partition offset is also 9. Fine. So, and there is no consumer connected to it, so the list here is blank. So again, if I reload it, so you can see the messages 11, 13, then every after 4 seconds we are publishing the message. So the latest offset is 14 now. So we have proved the concept here, which I was trying to explain is what, like when you are having a single broker with a topic which is having only one partition, then all the messages will be published to the single partition. So this publisher will publish all the message to the single partition. So that's what we are seeing. So we are seeing the same partition is getting all the messages 19, and here the sum of all the offset is also 19, and the latest offset in this partition is 19, which means all the messages are coming to this partition only. Hello people, this is Self-Tuts, and we are continuing our series on Kafka for beginners, and in this video we will see another concept of Kafka producer. So in the last video we just saw that there is only one producer and there is a topic with only one partition, and then we saw that how the messages are flowing. So in that case we found that all the messages will go to a single partition because there was only one partition in the topic. Now in this case we will be having one topic, but there will be two partition and the broker is same. So broker does not play an important role. Main thing is the topic and the number of partition. So in this case we have one topic and two partitions. So let's see how this particular configuration will behave. So single broker with two partition in a topic. So message will be published to both the partition. There is a single publisher only, and there are two partitions, so the message will be published to both the partition. It is not that only one partition will get the message. The message published will be random. Most of you people will think that it will be round robin, but it is not the case. So round robin means was one by one. So first only the zeroth partition will get, then the second message will be received by the first partition, then again 0, then again 1. So it is alternate. But in the case of Kafka, it is random, and I'm going to prove that using our demo. So basically when you're having two partition and a single producer or a publisher, then the message will be published to both the partition. So the first message can go to the partition 0. So this is our topic with two partition P0, P1. So let's say the first message comes, then the partition will be at P0. When the second message comes, it will go to P1. The third message will go to P0. It may happen it can go to P1, and the fourth message can also go to P0. So basically see, this is random. So first it was P0, then P1, then again P0, then again P0. So it is not alternate or round robin, it is random. So that you need to understand, and both the partitions are getting the message. We'll go to our Kafka manager, and here you can see that this is the Self-Tuts cluster that we are using, which we created in previous video. Now I have deleted the previous topic that was created, and here only one consumer offset is one consumer offset topic which is predefined is present. In the last video we have already created the registered user with one partition. I have deleted it, and now what I'm going to create the same topic with two partition. So I'll define here 2 and then hit create. So go to the topic view, and now this time you can see here there are two partitions, 0 and 1. In the last video what we have seen, there was only one partition P0, but here what we are seeing, there are two partitions 0, 1, and the latest offset is 0. So it is nothing latest offset, the total sum of offset is also 0, and the latest offset here is also 0, which means that no messages have been published till yet. Fine. Now what we are gonna do, we're gonna go to our IntelliJ IDEA where we are doing the coding stuff, and this is the last code that we have already written. So there is a Kafka producer that we have created, and the Kafka producer uses this bootstrap server to connect to the Kafka cluster. So basically this is the bootstrap server IP address and port. The port is default by 9092. Then we have defined a value serializer, because whenever you want to send the message to Kafka, it should be serialized. So what we are doing, we are taking a JSON value, and this JSON value is coming from this get registered user. So this is the registered user. We have used a Faker library. So we have seen this in previous video only. So I'll go back here, and then we are using this JSON serializer to serialize the data. Finally, what we are doing, we are sending the data using this producer to registered user topic, and the registered user is this, and I'm also printing the registered user, and we are also putting it inside a while loop so that the message is being sent continuously with a sleep of 4 seconds, which means that after every 4 seconds only the message will be sent. So let's try to run this program. We are not going to change it because we are going to prove what, that the message sending is random and it will be pushed to or published to both the partitions. So let's just run it. Okay, so the first message is published, then after 4 seconds the second message is published. Let's go to our Kafka manager and try to reload it. So we got two messages, and if you see here, both the messages are published to the partition 1. It is also not that it first assigned it to 0. The message was received to partition 2. Then again see here, we also received some message in partition 3. So 3 plus 2 is 5. So the total offset is 5, sum of the partition offset. So all 5 messages were published, 3 in this and 2 in this, and the total messages also here you can see it is 5. Now let's reload it again, and you can see here this is 6 and this is 3. If it would have been random, then the difference, if it would not have been random, then the difference will always be of -1. It may have that 1 is having 1 more than 0 or 0 is having 1 more than 3. But since it is random, so you are seeing a difference of more than 1. So that's what I'm saying, that when you are publishing the message, it is random. It can go to P0, then P1, and then the next two messages can go to P0 only. So this is whole random. So I think I have proved my point here, and you have also understood that the publisher randomly sends the messages to a particular partition. So I'll just reload it, and you can see here this is again 12 and 8. So the difference is of 4, which means that the message sending is random. So this was all about this video, that how you can have two partition in a topic, and there is a publisher and the message sending is random. Hello people, this is Self-Tuts, and we are continuing our series on Kafka for beginners, and in this video we will send that how a producer can send message to a particular partition of a topic. So in the previous video we have seen that the message sending is random, which means if there is a publisher and if there is more than one partition, then the messages are sent to the partition in random order. So one partition can get more messages than the other partition. But in this video, what we are trying to achieve is that the producer will send message to only a particular partition, so that you can tightly couple, means you can make a tight coupling between the producer and the partition of a topic. So let's see how we can do that. So we'll take an example where there are two partitions and the message will be sent only to one partition. So as we know that the producer can select the partition of their choice in the topic, in a topic where it wants to publish the message. So if you are having a producer, then it can select the partition of its choice, and the message will be published only to that partition. All the messages will be published to the single partition P0. So in our case, we will be creating two partitions, that is P0 and P1 for a topic, and we will try to publish all the messages to P0. So let's say this is the topic which is having P0 and P1 as the partition. So our publisher will only send the messages to P0. Now, When you're defining a Kafka producer, then you can get a partitioner method for that, and this partitioner method will get three arguments, that is key bytes, all partition, and available partition. Key bytes is what? It is basically the value of the key. Now till now we haven't discussed this key when we are sending the messages, and we will not discuss as of now. We'll see it in later videos. All partition is equal to the total number of partition for that topic. So in this case it will be 2 because we are having P0 and P1. So the all partition value will always be equal to 2. Now the available partition is equal to which partition are currently available when the publisher is trying to send the message to this particular topic. So these are the three parameters that will be present inside this partitioner method. Now let's go to our Kafka manager and let's see our setup. So we have already created this particular cluster, that is self-tests in the previous videos. I have deleted the topic which I created in the last video, that is a registered user, because that was having two partition and messages were already there. So I'll be creating the same topic again. So I'll create topic and then registered user, and the number of partition will be equal to 2. I'll hit create. And then if I go to this topic view, you can see there are two partition, P0 and P1. So currently if I reload it, you can see the total latest offset is 00, which means that no message has been published. Now let's go to our IntelliJ IDEA, and this is the code that we have already written in previous videos. Now we'll modify this code to handle our scenario where the Kafka producer will publish to a particular partition, that is P0. So here what we can do is we can define a new key, that is partitioner, and that will be equal to what? Get partition. I'll be defining a method PRTITN. So get partition will be the method that I'm going to define. So I'll say def and then get partition, and this method will accept three parameters. What are those three parameters? First is key byte, second is all partition, and the available. So I'll say key, and then I'll say all bytes, a key, all partition, and then available. So this is these are just names which can be used. The value will automatically be given when this partitioner method will be called. So I'll say available. So these are the three parameters that will be present here. Now in our case, what we need to do, we always want to publish the message to P0. So I will be always returning the partition number as 0. So I'll say return 0, which means what? That whenever this get partition method is called, when the Kafka producer is trying to send a message, so it will always get the partition number as 0. Everything has been done, that is we have defined a Kafka producer with this partitioner, and the get partition is there, and we are always returning 0. And inside this name main method, we are calling a while loop where the registered user is got, and then we are sending the registered user. So let's start this server, or let's start this producer to send the message. So I'll say run, and the first user has been sent, and after 4 seconds the another user will be sent. So these are random users. So again after some 4 seconds the third user will be sent. Now let's go to our Kafka manager, and if I do a reload here, you can see the latest offset is only increasing in partition 0, and there is no messages in partition 1. So if I reload it again, the message is again in partition 0 and nothing in partition 1. Why? Because we are always returning 0 as the value inside this get partition. So every time whenever this Kafka producer is sending the message, it will send it to the partition 0. So that's why if I again reload it, you can see it is 11 here, but here it is 0. So we have proved the theory this also, that a producer can be tightly coupled to a particular partition, and it will send the message to only those partition. If I see the offset, it is 11, that is sum of all the partition offset, which means what? The total messages that had been published to this topic is 11, and the 0 partition is having the total latest offset is equal to 11. So all the messages is coming to this partition 0. So I think you have understood this concept of sending the message to a particular partition of a topic. Hello people, this is Self-Tests, and we are continuing our series on Kafka for beginners, and in this video we will understand what is consumer in Kafka. So in the previous videos we have seen that what is producer and how producer were able to send messages to Kafka topic, which in turn was stored in Kafka topic partition. In this video, we'll go into the depth that how a consumer is represented inside a Kafka ecosystem and how they are able to consume the messages. Consumer are the Kafka component that consume messages from the Kafka topic. So if you see a consumer in the Kafka ecosystem, then they are components that consume messages from the Kafka topic. Internally, consumer consume messages from the Kafka topic partition. As we have seen in the video of publisher or producer, that actually the message is stored inside Kafka topic partition. So in the case of consumer, the consumer actually consume the messages from Kafka topic partition. Let's say this is a topic inside the Kafka ecosystem. So I have represented it with this shape. This topic contains what? It contains three partitions, P0, P1 and P3. So I have not written P2. So it is P0, P1 and P3. There is a consumer C1 and this consumer C1 is doing what? It is consuming messages from P0. So there will be a publisher here and they will publish it to the Kafka topic, and the Kafka topic will store those messages inside the topic partition, and these consumers can listen on these Kafka topic partitions, and from there they can consume the messages. Every consumer is always assigned a consumer group. So we'll see in the subsequent videos that what is consumer group and how it is very much important in the Kafka ecosystem. But for now, you need to understand that for every consumer, there is a consumer group. A consumer group can be represented like this, which means that it is a logical entity which constitutes one or more consumers. So for now, you just need to understand that every Kafka consumer is registered inside a Kafka consumer group. They cannot exist independently. If no group ID is provided, then random group ID is assigned. So let's say you're creating a consumer and you haven't provided any group ID to it, or you are not registering that particular consumer to any Kafka group. Then what will happen? Any Kafka consumer group. Then what will happen? A random group ID will be created and that consumer will be assigned to that particular random consumer group ID. We have already seen in our previous videos that we are using this Kafka Python as our library through which we can connect our Python application to the Kafka cluster. When you're writing a consumer, then the consumer should know about some configuration, then only it can work. So the first configuration is what? From which topic the consumer is about to read. So a consumer must know that I'm going to read from which topic. So you need to give the topic name and then only consumer can consume from that topic. After that, you need to define the bootstrap server in the consumer configuration, because you need to make the consumer understand that from which Kafka cluster you are going to read the messages. The third one is what? It is group ID. So you need to assign a group ID to this consumer so that they can register themselves to a consumer group. If you have not provided it, then also the consumer will run, because Kafka internally creates a random group ID. This is all about a consumer. So this is basically a consumer instance. It is not a consumer group. We'll understand in the next video that what is consumer group. But for a consumer to run, we need these configuration, and a consumer is always assigned to a consumer group. So you need to keep in mind that consumer are the Kafka component which consume messages, and they are always registered to a consumer group. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we will learn about consumer group in Kafka. So consumer group plays a very important role in Kafka ecosystem, and if you want to design a very scalable architecture using Kafka, then you need to know about consumer group. In the previous video, we have seen that what is a consumer in Kafka, but in this video, we'll understand about the consumer group. Consumer group can be defined as logical grouping of one or more consumer. So basically, when you group together one or more consumers, then it logically forms a consumer group. It is mandatory for a consumer to register itself to a consumer group. So we have also understood in the previous video that if you're writing a new consumer, then it is mandatory for the consumer to register itself to a consumer group. And if no consumer group is provided, then internally Kafka will create a random consumer group. Let's say there is a consumer instance C1, then it cannot exist independently, which means what? It always needs a consumer group so that it can exist in the Kafka environment. Now, let's say there is another consumer instance that is C1, and if it is assigned to a consumer group A, then it can exist in the Kafka ecosystem and it can consume messages from the Kafka topic partition. Consumer instances are separate process, which means what? They run independently. When you write a consumer and when you run that consumer, then that particular consumer behaves as a separate process. Consumer instance of same consumer group can be on different node. Now, this is a very important concept that you need to understand. As we know that in production environment, we always use more than one broker for our Kafka cluster, and basically these brokers are distributed across different geo environment or geo clusters. Now, let's say we have three consumer instances in a consumer group. So what we are taking as an example that there is a consumer group and that consumer group has three consumer instances, which means what? Three consumers are consuming from a particular topic. So I'll just explain it here that let's say there's node 1. So this is a separate machine which is on a different location, and there is another machine that is node 2 which is also present on in a different location. Now let's say you have three consumer instances. So I'm writing here three consumer instances. So the consumer instance can be present on node 1, then the consumer instance C2 can be present on node 2, and the consumer instance C3 can be present on node 1. It is very important for you to understand that if you are creating consumer instances inside a Kafka cluster, then the consumer instances which belong to the same consumer group can exist on different machines. It is not that all the consumer instances for a consumer group will be present on a single machine, because we are using Kafka cluster, so it is distributed. We'll take an example here that let's say you are having a single topic and that topic has one partition and you are writing only one consumer. So in that case, what will happen? All the messages will be published to the P0 partition. So we are taking the partition name as P0, so all the messages will be published to this P0 partition. So I'm describing here that we are having a topic and that topic has a single partition P0 and it is present on a single cluster, that is the cluster has a single machine. So in that case, what will happen? This is the topic and there is a publisher. So this publisher will do what? All the messages will be published to P0 partition. So this publisher is publishing all the messages only to P0 because there is no other partition. Now what will happen? All the messages will be consumed by C1. So C1 is a consumer instance which is present inside this consumer group A. So in that case, all the messages will be consumed by this C1 consumer instance. Now let's try to prove this point. So what I'm going to do here is that I'm going to look into my Kafka cluster. So this is self-taught. So this cluster we have already done the installation process in previous videos, and currently what is there? There is only one topic and there is only one broker. So this topic is what? It is basically the consumer offset that is by default created by the Kafka cluster. Now I'm going to create a topic here and the name of the topic will be registered user. So in our example, what we are talking, there is a single partition in a topic. So the number of partition that I'm going to create is what? It will be single. So I've created it, go to topic view, and if I come here, so you can see there is a single partition, that is partition 0. Now what we are going to do is we are going to write a consumer instance and then we'll try to consume it from P0 partition or this topic only. So I'll go to my IntelliJ IDEA, and in the previous videos we were here in this code. So what I'm going to do here is that I'm going to modify some of the code, and the code will be what? I'm going to remove this partitioner which we have added in the previous videos. So I will ask my Kafka producer to push messages to any partition whichever it needs to, and I'm not giving any partitioner. Okay, so this I'm just removing the old code. Also, I'm going to explain this code that what I have written here. So okay, so now what happens here is that I am creating a Kafka producer which is connected to this Bootstrap server, which means what? This is the publisher and this is basically the Kafka topic which is present inside this broker, that is 192.168.0.10, which is running on my local machine. And then I'm creating a message which is get registered user, and this get registered method is present where? It is present inside this data module which we have created previously. So if I go here, then it is using what? It is using a faker module of Python which helps us to generate fake data. So every time there is a random data, so we are generating a data of user registration that contains name, address and created it. So I'll go here to the producer.py, and our producer is looking fine that we are sending messages to this Kafka broker, and there's a JSON serializer because we want to serialize the message and then only we can send. So what we are doing, we are just doing a JSON dump of the data and we are encoding it with UTF-8. Fine. So we got this registered user, then I'm printing the registered user, and then I'm calling the send method on this producer instance. So I'm calling producer.send and then registered user and then this registered user. Now I will write a new file here, that is the consumer. So I'll just create a new Python file and the name of the Python file will be consumer.py. And in here, what I'm going to do is I'm going to import the Kafka consumer. So I'll say from Kafka import Kafka consumer. Fine. So I'm importing the Kafka consumer and I'm also importing the JSON module. Now what I'm going to do here is I will just say that if name underscore name is equal to underscore main, so that I can run this file and this particular code will run. I will create a consumer. So I'll say consumer will be equal to Kafka consumer, and this will require some parameter. So the first parameter is what? It is the topic from where we are going to consume the message. So I'll just say registered user because I'm going to consume the message from that particular topic. So basically the topic name that I have written here is registered user. So I'm writing in my code that we are going to consume the message from this registered user topic. So I think the spelling is correct, or I'll just copy it from here. So I'll copy it and I'm going to come here and I'm just going to paste it. So it is fine. After that, what we need to do, we need to make the Kafka consumer understand that from which Bootstrap server we are going to consume the message. So we'll just say Bootstrap server. So we'll say Bootstrap and then servers is equal to what? We will assign the IP address. So I'm going to say 192.168.0.10 and then 9092. So this is the local Kafka instance that I'm running. If you are having some another instance like on cloud or something, then you can provide here. Now I'm going to assign a new value, that is what? Auto offset and then reset. So this will help the consumer to consume message either from the starting point or the latest. So what I'm saying it is earlier, so that you can consume from the starting, that okay, this consumer will start and it will start to consume from the first message that is published in the topic. And when the topic is being published, then what will happen? There is a consumer offset topic which is present inside the Kafka, which is created by default from the Kafka, and that will store the Kafka, this consumer offset for every partition which has been consumed by the consumer. So basically when the consumer will start to consume the message, then what will happen? Kafka internally maintains a consumer offset partition where it will store all the data for that particular consumer, that up to which offset this consumer has consumed the data, so that when again it will start, then it can start consuming after that particular offset from where it stopped last time. So we'll see it. Don't worry, that it is a very easy concept that you will understand. Then what I'm going to do, I'm going to provide it a group ID because we have discussed that we need a group ID. So I will say that it is consumer group A. So I'll just say consumer group A. You can provide any name, whatever you want. I'm just providing it consumer group A. So I'm giving a group ID also. Fine. Up to here, it is okay. Now what I'm going to do, I'm going to do just a print write, that is starting the consumer, and after that I'm going to print the message. So we can just say for message in consumer. So because we have created a consumer instance, so we can just say for message in consumer print what? I'll just say registered user. Okay, because we are publishing message regarding a registration, user registration, which we have created here. So we'll be publishing messages for this user registration, and then we'll consume the user registered. So I'll say user registered is equal to, and then we'll format the data. So the data dot format, and because when we are sending the data, so what we have done, we have serialized it. So now what we'll do, we'll just deserialize it. So we'll say JSON dot loads and then the data. So message dot value. So message.value is the value which will be present inside the message. So again, I'll show you in the producer what we are doing. Before sending the data, we are serializing it. So we are dumping the data with JSON, which means we are serializing it. So when we are consuming the message, so what we are going to do, we are going to deserialize it by using JSON.loads. This consumer is fine. I think we are just taking consumer. We are saying that, okay, from this topic, we are going to consume what is the Bootstrap server. Okay, this is the Bootstrap server, which is the locally I am running. And then we are saying that whenever you start and you are a new consumer, then start consuming from the earliest. Then what, we are also providing a group ID. So everything is fine. Now what I'm going to do is I am going to run this consumer from here. So I will say Python and then consumer.py. So what this is going to do, this has starting the consumer. Fine. Now you can see there is no message getting printed because there is no message inside our Kafka partition. So I'm going to see here the registered user and there is no partition. There is no message in the partition. Also what I'm going to show here is the consumer consuming from this topic. So there is no consumer that is consuming from this particular topic. It has not started, so it is not getting listed here. Now what I'm going to do, I'm going to start my producer. So I will come here and then I'll just say run. So you can see on the right hand side, it will start to consume, and on the bottom here, it will try to produce. So see, Teresa Crawford, and here you can see registered user is coming. On the right hand side, it is consumer and it is producer. So 3 user is there and 3 users are here. So you can see it will just produce and it will consume. It will just produce and it will consume. So what is happening here? The publisher or the producer is sending the messages to this partition and the consumer is consuming the message. So this consumer is C1, which we have just run, Python consumer.py. Now we'll go to our Kafka manager here. And if I reload it, then you can see that, okay, the latest offset is 8, which means 8 messages have been published. And here you can see consumer consuming from this topic. So this is consumer group A. If I go here, then there is some data, that is what is the consumer instance owner. So when you're starting the consumer, it got a random consumer ID or name. So consumer group is common, consumer group A, but you got one only. So it is basically a random consumer instance ID, but the consumer group is the name that we have provided. Again, if I come here and reload it, you can see the number of offset is 17. And if I count here also, if I come here, so you can say 18 messages have been read. So now see, 17 is here. If it is 19 and if I go here, so it is 19 messages have been read. There's a lag one, which means when we reloaded it, this was not read. If I do it, it will again increase. So it is all the messages which are being published to this partition is getting read by this consumer instance. If you see the partition also, I'll go to this consumers. Not consumer self-starts here. Then there are 2 topics. I'll go to this registered user. If you see, there is a single partition P0. All the messages are being published here and all the messages are being read by this consumer. So in the scenario of one topic, one partition, one consumer, the publisher will publish all the messages to this topic partition and the consumer C1 will take that messages and it will print it what we have written here. So message is being sent from here and it is printed here. So I hope that you have understood this concept. When there is one partition and one consumer, then how your Kafka ecosystem is behaving. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we'll continue a different scenario of consumer group in Kafka. So in the previous video we have seen that what happens when you have only one partition and one consumer. But in this scenario what we are going to see that the topic is having 2 partitions and there is one consumer. So how our Kafka ecosystem is going to behave, how the consumer is going to consume the message, we'll learn about that. So message will be published to the partition randomly. Since we are having 2 partition and there is a producer, so the message will be published randomly. Now message will be consumed by C1 in the round robin. So if you are having a single consumer, as we have told you earlier that we are having 2 partition and a single consumer. So in that case, what is going to happen? The C1 will consume the message in a round robin, that is one after other. So let's say this is a topic inside your Kafka cluster and there are 2 partitions P0 and P1. So these are the two partitions inside this topic. Then what is going to happen? First, the consumer C1, which belongs to consumer group A, will do what? It will read messages from P0, and there is a publisher here on the left hand side which is going to publish, means infinitely, that it is messages are being published whenever they are being originated from some source. So the publisher will start publishing the message, and it can be random. 2 messages can go here, then the 3rd here, 4th here, 5 here. So it can be published in any manner. But the C1 is going to do what? It will always consume the message in a round robin manner. So basically this C1 will consume from both. So first time it will consume from P0, then again it will consume from P1, then again C1 is going to consume from P0. So this is going to work like that, which means what? If your topic is having 10 partitions, then the single consumer will read all the messages from all those partitions. It is not that it will just read from one partition. It is going to go starting from P0, then P1, then P2, then P3, then up to P9. So what I'm going to explain here is that a single consumer instance inside a consumer group is going to read from all the partitions when there is a single consumer group and which contains a single instance, and the partition is more than one. So it will consume from all the partition. So that only what we have said, that one consumer can consume from more than one partition. So this is a concept that you need to understand, that in a consumer group, one consumer can consume from more than one partition. It is not that the consumer is tightly coupled to a single partition. It can read from any partition. Let's see how it is going to behave. So this is my Kafka cluster, which we have seen in the previous videos also. So I'm inside the self-touch and I have cleared all the previous data, and it is just fresh Kafka cluster that is present. So it is having only one topic, which is the default topic which Kafka creates itself, that is consumer offset. Now we are going to create a new topic, and the topic name will be registered user. And in this, what we are having 2 partitions. So I'll select the partition as 2 and then just create. Now if I go to topic view, so here you can see there are 2 partitions, 0 and 1, and currently there is no message. So the latest offset is 0. Now I am going to do what? I am going to start a single consumer. So in our previous videos, we have done this coding in IntelliJ IDEA, where we have created a consumer and where we have created a producer. So the producer is doing what? It is creating a producer instance, and it is getting connected to this Bootstrap server. Then it is serializing the data, which is important because we want to send the data in a serialized manner because that can flow over the wire. But if you're sending an object, then it will throw error. So we are just serializing this JSON object by doing a JSON dump and then encoding it with UTF-8. Once it is done, the producer instance is there. Then what we are going to do, we are going to use the send method, that on which topic we are going to send the message, and we are getting the data, this registered user, from this method get registered user, which is written inside this data. So this is using a faker module to generate some fake data, and it is random every time. So I'll just go here back, and finally we are putting a sleep of 4 seconds, so that after every 4 seconds data is sent to the consumer. I am going to start the consumer. So I'll start a terminal, and it is here. So in my diagram, you can see that there is a consumer. So we'll start a single consumer. So I'll just say, or I'll explain you the consumer code also. So the consumer code is nothing but we are creating a Kafka consumer instance, and we are asking it to consume from this registered user topic in which we are publishing from the producer. So in the producer, we are publishing it inside this topic. So we are asking the consumer to read from this topic only. And then we are also providing the Bootstrap server, that is the Kafka cluster, from where we want to consume the message. Then the auto offset reset is what? It will, when the consumer instance will start, that is a new instance is starting, then it will always read from the 0th offset, means from the starting. And then we are also providing a group ID, which we have seen in this, that is, this is the consumer group A. So we are just saying consumer group A. So we are registering it inside a consumer group. Now we are printing it, and for every message in the consumer, what we are doing, we are printing the data, and we are just deserializing it by using json.loads. So up to here it is fine, and I'm going to start this consumer just by writing Python and then consumer.py. So the consumer has started, but there are no messages, so it is empty. Fine. Now what will happen? I'll start the producer. So this producer is going to do what? It is going to push the message to both the partition, and we can confirm it there. So I'll just start it and run. So now you can see that we published a message and that same message is printed here, that is registered user. The second name registered user and the same second registered. The third registered user, you can see the name is Ronald and here the third registered user is Ronald. Now first thing that we need to confirm is that the data is going to both the partitions. So I will come to my Kafka manager here, and here if I reload it, you can see, okay, the latest offset is this. Okay, you can see the data is going to 6 is here and 1 is here. I will again reload it. You can see 6 is here and 3 is here, and you can see it is random. So 6 was already published here, and after that 3 messages were published here. So it is fully random that how the messages are getting published. So if I again reload, there are 7 and 4. So we have proved one point, that is what the messages will be published to partition randomly and it will be published to both the partitions. So we can see here partition 0 is also having message and partition 1 is also having message. Now the second point is what? The C1 is going to consume from both the partition. It is not that it will consume from only one partition. So let's see our consumer group this. The first thing is what? We can verify by counting the messages which are coming here. So let's say every time the message is coming here, it is getting printed here. So it is getting published here and it is getting printed here. So this is a view that you can say that okay, it is getting published, but now I'm going to prove it from the Kafka manager. So okay, now you can see here the total offset is how many? 10 plus 12, that is around 22. And if I go to this consumer group, so the log size is what? 11 and 3. Okay, so the consumer offset 0 and this is also about 22. So as I just reloaded it, so it is going to increase. So you can see the number of messages are increasing. So if I do a sum of this, that what is the consumer offset? 11 and 16, which means what? It has read 11 messages from partition 0 and 16 messages from partition 1 basically. So this is consumer offset and the sum will be equal to the total messages published. So I can just make it better for you to understand that. I'll come here in self-tuts. Then there are two topics. I'll just keep the registered user and I'll see the sum of partition offset, that is 32, and then I'm going to duplicate it. Fine. So when I'm going to duplicate it, I'll just make this one on the right hand side and this on the left hand side. Fine. If I come here and I'll click on this consumer group and here, so I will reload both of them at a single time. So let's say this is reloaded and this is reloaded. Now let's see, there are 41 messages, that is sum of the partition offset, and here also it is 41, that is 20 and 41, which means what? This consumer is reading from both the partitions. So the consumer offset is 20 and this is 21, and it is also saying that from 0 partition it is reading 20 message and from 1 partition number 1 it is reading 21 message. So we have proved our point is what? It is the message publication is random, but the consumer is going to read it in round robin manner, and the important point is what? It is going to read from both the partition. Hello people, this is Self-Tuts and we are continuing our series on Kafka for beginners, and in this video we will understand another scenario related to consumer group behavior in Kafka. So in the previous video we have seen that how the consumer is going to behave when we have multiple partition but a single consumer. In this video, what we are going to do, we are going to see that how the consumers are going to behave when we have a single partition but multiple consumer. So in this thing, you need to note that the partition is single but the number of consumers are more than 1. So here both the consumers are registered to the same consumer group. So the first prerequisite that we are saying is what? Both the consumer instances that are running are registered to the same consumer group. So let's say this is the topic and it has only one partition, that is P0. So this topic is present inside a Kafka cluster and it has only one partition, P0. Now we have two consumer instances, C1 and C2, and they are registered to the same consumer group. Our C1 consumer will start to consume from partition P0. But what will happen? One consumer will be sitting idle. So this C2 consumer is not going to consume anything from this partition 0. So from this we can understand an important concept of Kafka is what? Same partition can't be assigned to multiple consumer in the same group. So if there are some partitions present there inside a topic, so the same partition can't be assigned to multiple consumer in the same group. So if the consumer belong to the same group, so the same partition can't be assigned to them. If there are more than one partition, so let's say P0 and there's P1. So P1 can be assigned to C2, which we'll see in the next subsequent videos. But the important point is what? Inside a topic, same partition can't be assigned to multiple consumers inside a same consumer group. So I think this concept is clear, and this will help you to design a better architecture using Kafka tools or Kafka ecosystem. Let's see this in our demo that we'll be creating two consumer instances, and there will be a topic with a single partition. So first I'm going to do is what? I'm going to go to this Kafka manager, which we have installed in previous videos, and we have already linked this Kafka manager to our Kafka cluster. So I'll just open it, and I have cleared all the data which I did in the last video. So currently there is only one topic which is the default topic that Kafka creates, that is consumer offset. Now what I'm going to do is I'm going to create a new topic, and the name of the topic will be registered user. And from our configuration, what we are going to do, it is having a single partition. So I'll just give one partition and create it. If I go to the topic view, I can see here there is a single partition, that is 0. And if I reload it, then the latest offset is 0, which means no message has been published yet to the partition. I'll go to my IntelliJ IDEA, and here you can see that we have already written some code before. So there is some producer and consumer. So producer is doing what? It is basically creating this producer instance, and then it is getting this data, that is get user registered, which uses the faker module of Python to generate some fake data like name, address and year. So this data is present inside this registered user, and then we are sending this registered user data to the registered user topic which we have created here. So basically this is the registered user topic in our Kafka cluster, and we are sending that to this data, registered user data, to this topic, and the interval is of 4 seconds, which means the data will be sent only after 4 seconds. The diagram says what? It says that we are having two consumers inside the same consumer group. So let's go to this consumer.py, and here you can see that I have created a consumer instance, and this is listening to the topic registered user. So this Kafka consumer is going to what? It is going to consume the messages from registered user, and the bootstrap server is this, which we have discussed in previous videos. If you are not familiar with it, then you can refer to the previous videos so that you can get a better understanding. Once the Kafka consumer is there, then we are doing a simple print that's starting the consumer, and after that we are consuming the messages. Now in our slide we have shown that there are two consumers, C1 and C2, which is connected to the or registered to the same consumer group. So what I'm going to do, I'll start two consumer. So the first consumer I'm going to start is what? It will be Python consumer.py, because the name of the file is consumer.py, and we have already written the code here. So it will start the consumer, and the most important thing is what? The group ID is consumer group A. So I'll just run this file. Fine. So it is started, and it is saying what? Starting the consumer, which is this log write. Since we don't have any messages, or we haven't published any messages, so there's no log write as of now. Now what I'm going to do, I'm going to split this terminal vertically. I means horizontally, and then again we are going to start the new consumer, that is C2. So the consumer will be same, but the instance is different. Why? Because we are running it separately. So I'll say Python consumer.py, and this consumer is also registered to this consumer group A, which we have shown here, consumer group A. Fine, I'll start it. So everything is working fine. We have started two consumer. Now what we'll do, we'll start pushing messages to P0, because we have created only one partition here. As you can see, there is only one partition, which when we defined the topic using create topic, there was only one partition. So there is one partition, and this producer is doing what? It is sending messages to this registered user topic. So now let's see, I'll run this, and what will happen? Only at one place we are going to get the log write, either at this or either at this, whichever consumer will get first assigned to that topic. Both will not get the message. Because why? Because in the slide we can see that the same partition can't be assigned to multiple consumer in the same group. So let's run it and prove our theory. So I'll just run it, and you can see we have started publishing the messages, and this consumer got registered to that partition. So you can see here I'm getting the messages here, but I am not getting the messages here. Fine, you can see it is messages are present here, but it is not coming here, even though the consumer is up. Now what I'll do, I'll just reload this, and you can see that I'm having this consumer group A, and it has only one consumer instance being shown. Because why? The partition 0 is attached to only this consumer instance, and the second consumer instance, it is there, but it has not been assigned any partition, so it is sitting idle. So I think you have understood this concept, because you need to take care of these things when you're designing a Kafka related system or Kafka related architecture. That same partition can't be assigned to multiple consumer in the same group. If they are in different group, let's say this C2 is in different group, then this C2 will also consume the message. But if it is not there, then it will not consume. Let's say we'll change it here. Okay, fine. So this is consumer C2 and I have done control C. Now what I'll do, this consumer has stopped. So I'll come here and I'll just give this consumer a different group, that is group B. Fine. So here this is already running. So if I'm changing the file, there is no effect because that consumer instance is already running. So now I've changed the consumer group, and if I do what, python app.py, python consumer.py, so what will happen? It will start a new consumer instance, but this consumer instance is attached to a different group. It is not attached to this consumer group A, it is attached to consumer group B. So this will also start getting the messages. So let's see and let's prove this theory. Okay, now you can see all the messages, because we have given earliest, so that's why all the messages were there. Now for every publish, both will get the message. So you can see same name Matthew, and here also Matthew, and from here also Matthew has been published. So Robert, and then here Robert, and here also Robert. So I think you have finally understood it, that inside the same consumer group, two consumer instances can't be assigned to the same partition, but if they belong to different consumer group, then everything can work fine. Hello people, this is Self-Tuts, and we are continuing our series on Kafka for beginners, and in this video we'll understand another scenario related to consumer group in Kafka. So in the previous video we have seen that how the consumer is going to behave when we have single partition but multiple consumer. But in this one, what we are going to see is that there are multiple partition and multiple consumer. So for the sake of this example, I have taken two partition and two consumer. So how my consumer group is going to behave, or the consumer instances are going to behave. So we are taking this example, that is two partition and two consumer. Now the prerequisite is what? Both the consumer are registered to the same consumer group. So we have understood about the consumer group, and what we are saying that the consumer instances that we are going to create are registered to the same consumer group. Now let's say this is the topic which has partition P0 and P1, because we are saying two partitions are there. And what will happen? We have two consumers C1 and C2. So C1 will be assigned to P0 and C2 will be assigned to P1. Okay. So whenever you have more than one consumer instances inside a consumer group and there are multiple partition, so what will happen? This means one of the consumer instances will be assigned to a partition and the another consumer instance will be assigned to another partition. So this is the case for two partition. If it is three, then what will happen? The consumers will switch between the partitions every time. So this can, C1 will take from P0 and then from P3, or either C2 can take from P1 or P0. So what I'm trying to make you understand that if you have multiple partition and multiple consumer instances inside the same consumer group, then what will happen? The partition will be assigned to a particular consumer instance and they will be able to consume from it. Let us see this in a demo, that how this is going to behave. This is the Kafka manager that we are going to use. If you are not familiar with Kafka manager, then you can go to my previous video and you can install, and then you can attach the Kafka manager to a Kafka cluster instance. So this is the Kafka cluster Self-Tuts name, and there is a topic by default here. This is the consumer offset topic which Kafka itself create. Now what we are going to do, we are going to create a new topic and the name of the topic will be equal to registered user. In the example, we are taking the number of partition as equal to 2. So I'll create the number of partition is equal to 2 and then I'll hit the create button. Okay, so go to the topic and here you can see there are two partitions, 0 and 1. So up to here we have done, that is the topic is there and two partitions are there. Now let us go to IntelliJ IDEA where we are doing the coding for our this demo and other stuff. So basically we have created two files, producer and consumer. So the producer responsibility is what? It is able to push messages or publish messages to this registered user topic that we have created just now. So in the Kafka manager, we have created this topic and the publisher is written, which will create this publisher or producer instance, and after that it can publish the message. So this is get registered user. It is basically a demo method which we have written, and that is generating a fake data and returning the registered user. So I'll go to the producer again, and after you get a registered data, you just print the registered user and then you send it to registered user topic. There is also one thing that after an interval of 4 seconds we are publishing. So after every 4 seconds we'll be publishing the registered users. To here the producer is done. Now let's go to consumer, and this consumer is doing what? It is reading from the registered user instance and it is assigning itself or registering itself to consumer group A. So basically in our example what we have done here is this consumer instances are assigned to this consumer group A. So it is assigned to the same consumer group, and in our code also we will be doing the same, that we are assigning it to the same consumer group. So after it has been assigned to the same consumer group, it starts to read the message and it starts to print the message. So I'll open my terminal here and I'll create the first consumer instance. So first consumer instance will be what? It will be started using Python consumer app.py. So this has started, but there is no log write or there is no print because we have not started publishing the messages. I'll split this terminal horizontally and again I'll start a new consumer. So when I start a new consumer, which means what? I'm creating a new instance of the consumer which is registering to the same group ID, that is consumer group A. So I'll come here and I'll again start Python consumer.py. So this will start a new consumer instance. So up to here we are done. C1 and C2 is done, and also the topic has been created with 2 partitions. Now we will try to publish the message to this Kafka topic, and the publisher will publish the message to P0 also and P1 also, because we have seen the publisher will send messages to both the partition randomly. So now coming on to the IntelliJ IDEA, there's producer and we'll just start it. So whenever I start it, you will see that the message is coming to both the partitions. So I'll run it and you can see the first message came here and it went to this. After that the second message came here, it went to this. The third message, it is coming here. Then here the fourth message and it will go here. Then let's see where's the fifth message. Okay, fifth message got to this consumer 2. So both the consumer instances were assigned separate partitions and they are reading it from there. Now let's go to Kafka manager, and if I do a reload, you can see both the partitions are having 3 messages. Let us offset. If I again reload it, it is 4. Fine. So these are the 4, and if I go to consumer group, you can see there are 2 consumer instances. One is consuming from partition 0 and one is consuming from partition 1. And you can see the numbers are different, 524, 394. So basically this is a random UUID generated for every consumer instance that you are going to create. This is the topic. It has 2 partitions, P0 and 1, and there is 7 and 8 messages here, and both are being read by the consumer instances. So again, if I see here, okay, so it is publishing, Milan is published, and you can see here we got, okay, let's say Tammy, here is Tammy. Let's see Jessica is where? Jessica is again here in the consumer 2. Let's say Ashley, and Ashley is again in consumer 2. Let's see when we'll get here. Okay, Rebecca is again here. And then we have Brian is again here. So I think message, yeah, then Sarah is here. So basically the publishing of messages is random, and the consumer are consuming the messages as soon as it is published to that partition. So I think you have understood the concept. The concept is what? Whenever there is a producer and the number of partitions are 2 or more, and these consumers are more than 2, then they will consume from every partition which they are assigned to. So if there are 2 partition and 2 consumers, so one will be assigned to this and C2 will be assigned to this, and they will start consuming from it. Hello people, this is Self-Tuts, and we are continuing our series on Kafka for beginners, and in this video we will understand what is replication in Kafka. So you must have encountered a term known as replication factor when you are creating a topic or when you are learning about a Kafka topic. So we'll go into the depth that what is replication factor or what is replication in Kafka. We have discussed in our first video that Kafka is a fault tolerant system. So this is one of the most basic property of any Kafka ecosystem or Kafka cluster, that they are fault tolerant, which means what? The fault tolerant specifies, or it denotes that the ability of a system to continue operating without interruption when one or more of its components fail. So here the important point is that one or more component is failing, and even though the components are failing, but my system is operating as expected. So this can be thought of as a magic, like, okay, my systems are failing, but even though the system is working properly, how can this happen? So all these can happen through this new terminology or new things that is being developed that is called as distributed system. So Kafka is fault tolerant and it is distributed. So what is a distributed system? Which means that it behaves as a single node or a single system even though it is distributed on multiple nodes. Okay, so the components are deployed on multiple servers, but for a user, it seems that it is a single system. In Kafka, each partition is replicated across multiple servers for fault tolerance. So how this fault tolerance can be achieved? It can be achieved by replicating the partition of the topic. Since Kafka ecosystem resides on multiple servers, that's why the partitions are replicated across the multiple server. We'll see a detailed diagram of this. So if there are multiple partitions, then only one partition will be active at a time and called leader. Since the partition is replicated, so let's say there's a partition 0, it is replicated. So there can be 3 instances of partition 0, but only one partition or only one instance will act as a leader. The other partition will only replicate the messages and call followers. So the main partition is called what? It is called as leader, and the other partitions are called what? It is called as followers. So from here, the other partition means that which is replicated partitions of the same partition. This concept of leader and follower will be clear when we'll see it pictorially. When there's a leader and there's a follower, then the leader handles all the read and write requests for the partition while followers passively replicate the leader. Which means what? If you're pushing the data, then the data will be first pushed to the leader and then the followers will passively replicate the data from the leader. So this is one of the important concept, that only for a particular partition, one instance will be acting as a leader and the others will be acting as the follower, and the data of the read and write will be handled by the leader and the followers will passively replicate the data. We are taking an example where there are 3 brokers, which means what? There is a Kafka ecosystem or Kafka cluster which constitutes of 3 brokers, and for the 3 broker we are taking a single topic and that topic has a single partition and the partition has a single replication. So let's say this is a Kafka cluster. So this boundary defines the Kafka cluster and you have broker 1. So this can be a separate physical machine on AWS. Let's say it can be EC2 instance, or on Google Cloud, it can be another compute engine, anything. So this is basically a system, which means it can act as a physical system or virtual machine, anything. There is a broker present here. Now there is another system where the broker 2 is present and there is third system where broker 3 is present. Since it is a Kafka cluster, so all these 3 broker constitutes and create a single Kafka cluster. So you have Kafka installed here also, and here also, which means on broker 1, 2 and 3. Now this is the case of what? There are 3 brokers. Now let's say there is a single topic. So the topic will be present here also, the topic will be present here also, and the topic will be present here also. Now the topic has a single partition, which means what? There's only one partition, that is partition 0. And it has only one replication. So in that case, what will happen? There will be only one partition, that is partition 0, and it will be present only on broker 1. Even though there are multiple brokers, but since the replication factor is only 1, which means what? The partition 0 will be present here on broker 1 only. And this is called what? This is called the leader partition. Since the partition 0 is present here only, so it is called leader partition. And why it is present only on broker 1, even though we are having multiple brokers? We are not using these brokers because the replication factor is set to 1. So now I think you have understood. If there is a topic or the replication factor of the topic is 1, which means what? All the partition will have only one single instance, and that single instance will be called as leader. Coming on to the second example here, what we are taking there are 3 brokers, 1 topic, 1 partition and 2 replication. So we'll understand it pictorially. So let's say this is the Kafka cluster and there is again broker 1, broker 2 and broker 3. Now in this case, what we are taking an example of a single topic, because the same rule will be applied for the multiple topics, that is different topic. So let's say there is a single topic. So the topic will be present here, here and here. So on all the 3 brokers we have topics. Now the partition is 1, but the replication factor of the topic is 2. So since the partition is 1, so we can say that only 0 is present, means 0th partition is there. If there are more than one partition, then it can be 0, 1, 2, 3 something. So let's say the partition is 1 but the replication factor is 2. So in this case what will happen? We are saying there is a replication factor, which means there will be another instance of this partition. So first of all, this partition will be called as leader, and the second partition will be there, and this will be called as follower. So now you can see that we are having three brokers, broker 1, broker 2 and broker 3. Since we have given the replication factor of the topic as 2, which means what? One will act as a leader and the other will act as a follower. So when the leader is active, all the read and write are going through this particular partition, that is partition 0. And whenever you push a data here, the data will be replicated to this passively. So that is internal architecture of Kafka, how they do the replication and the thing. We are not interested in that. We just want to understand the concept that whenever you push the data to the leader, then the data will be replicated to the follower. And since we are having replication 2, that's why for this partition 0, we have one as leader and the other is called as the follower. Now let's take the third example. Third example says what? There are three brokers, which is as the previous example, one topic, one partition, but the replication factor is 3. Since we are having this Kafka cluster, which has broker 1, broker 2 and broker 3, because we are taking the Kafka ecosystem to have 3 brokers and there's a single topic. So topic will be present here also, and here also. The partition has 3 replications. So you can guess that one of the partition will act as the leader and the other 2 will be acting as the follower. So let's say this is the first partition, that is partition 0, and it is the leader partition. Now since the replication is 3, so what will happen? There will be another partition here and there will be another partition here, but these 2 are follower. So all the data read and write will happen to this leader, but the follower will passively replicate all the data and all the configurations related to this particular partition. So whenever you are saying the partition has 3 replication factor, which means what? There will be 3 instances of that partition, out of which one will be acting as the leader and the other will be acting as the follower. But you should understand that why this is important, why this kind of architecture is important. So let's say you created this ecosystem of Kafka cluster where there are 3 brokers and you have taken a single partition. Let's say there is only one partition 0 and the replication factor is 3. Now there is a producer here and it is pushing the data to this topic. So what will happen? The data will come to the leader. Why? Because the leader handles the read and write. So whenever, suppose you are pushing some data, so data came here, it went to 0, then again 1, then 2, then 3. Now what is happening? Internally the data are being replicated here, and the Zookeeper knows that for this particular topic and for this particular partition, which is the leader partition. So there is Zookeeper, as we have learned in our first or second video, that what is the importance of Zookeeper. So Zookeeper will know that for a topic and for a partition, which is the leader and which is the follower. Now let's say this particular node goes down, the broker 1 node goes down, there was some power failure and the whole Kafka server and other things crashed. So what will happen? Since the data was replicated to these followers, so data is not lost. So now what the client will do, or if there is some consumer, then what it will do? First it was reading through this broker 1 because the leader was present here. So let's say there is a consumer here, so it was reading here from broker 1 and the partition 0, and now suppose this particular thing goes off. So this particular broker 1 goes off. So what will happen? Zookeeper will automatically tell what? Okay, the leader which was present here on broker 1 has gone down, so I will make a leader out of these 2. So then what will happen? Based on some election algorithm or something, either of this particular partition or this partition can become the leader. So now what the consumer will see? Consumer will see that okay, this has gone, but still I am having data here. So I'll try to start reading the data from either broker 2 or broker 3. So you can see the magic. Even though one of the node is down, one of the broker is down, but as we have given the replication factor, so data was present here. That's why the consumer didn't fail. The whole application didn't fail. That is the meaning of the fault tolerant system. And this is what replication means in Kafka. So I think you have understood that what is replication and why it is needed. Replication is needed because you need to make your system fault tolerant, and your system should have the capability to work even though one or more nodes are failing. So I think you have understood this. So hope you like this video, hope you like my channel. Please subscribe to my channel and please share these videos with other people. Thank you.